Welcome to the electronics class for November the 30th. So first of all, I've looked over the midterm exams that you guys turned in, and in almost all cases, it worked out really well. You guys did a great job. Um, some of you had just a little bit of trouble, but most of you did well. So congratulations on that. I hope that you went and told your parents, hey, I learned how to add 2 plus 2. Yay. Okay, so between now and the end of the school year, or I'm sorry, the end of this semester, which is when this class ends, you guys realize this is just a half year class. So you might think that we got a month and a half, but in reality, we got 2 weeks of winter break in there. So we really don't have much time between now and the end of the semester. And you guys need to be aware that there is a state mandated test. It is not a test that I write. It's a test that some people at the state of Utah Office of Education write. And so there are a bunch of questions that they're going to ask you. And so many of the things that we've talked about will be on the test, or let me rephrase that. Many of the things that will be on the test we have talked about. And in my opinion, the things that are the most difficult are the things that we've talked about. But there will be a bunch of other things on the test that you need to know. And so we're going to spend the next couple weeks just kind of going over things not quite the way that we've been doing before, not with the end project of building something like a binary adder or whatnot, but basically just checking off a list to make sure that we know all the things we're supposed to know. In fact, I posted a list on Canvas, so you should all be seeing my Canvas page now. So if we go into the assignments tab here, or the modules tab, and then scroll down, okay, so you'll see there's a couple things here that I have on mine, but you don't have on yours because I haven't yet published them. This one right here, electronic components you need to know. All right, so if you click on that, it will take you to a document here, which you can download, or if you just click on this little icon here, it'll open up so you can view it. So these are all electronic components that you need to know. Now, that doesn't mean that you need to know in great detail how to use them. You just need to be able to identify what they are and give maybe a one-sentence description of what they do. But you don't have to worry about how to use them. So I've put this list on here, and I'm going to use it as a checklist as the next couple weeks go by, where I'm going to, at some point in the next couple weeks, talk about all of these items. But let's just go through and look at it right now. Don't worry if the list looks like it's really long. It's not as bad as it will appear. Okay, so let's start off with just, okay, so right there. So AC power supply. Well, that's what you do is you put that in your circuit in place of a battery. So let's suppose that you're going to plug something into the wall and you want to connect that into your circuit so that the wall is going to run your circuit rather than a battery. So this is what it would look like. You put that little circle in it with a little sine wave in it, and that just means that it's an AC power supply. So that's pretty straightforward. Nothing that you really need to know about that other than what it is. Okay, so this next one here, an ammeter. Well, that's just a multimeter like we've been using in Tinkercad, where it's set to read current. This one here is potentially confusing. The little triangle symbol looks like a logic gate. Remember the NOT gate, the inverter gate? So this one looks like that, but it's not. Notice it has two inputs, not just one. In fact, let me enlarge this just a little bit here. Okay, so it has two inputs, not just one. And so if they show you a schematic and they say, hey, what's that? Remember that if it's got two inputs, then it's not an AND gate. It isn't a NOT gate. It's an amplifier. Now, We are not going to study any more about amplifiers than we already have. What we have done is we spent a little while talking about how to use transistors as amplifiers. And so this symbol that you see right here, if you were to open it up and look inside, you would see that there are a bunch of transistors inside, plus a couple other things that we're not going to learn about in this class. But if you were to take an electronics 2 class, an intermediate or an advanced electronics class, then you would learn more about them. Oops, didn't mean to do that. Hang on a second here. I have to turn off this before I do. Okay, an antenna. We're not going to learn about those, but you just need to recognize, I mean, it looks like an antenna, right? So if we had a circuit that would broadcast electrical or electromagnetic waves, or pick up electromagnetic waves, like let's say we had a wireless receiver, wireless transmitter. So this would be the symbol for it. All right, so a battery, we've already talked about batteries. When I draw batteries, I normally draw the single cell battery, but you guys hopefully know that if you take several single cell batteries and put them together, you can get a battery that has higher voltage. That's considered a multi-cell one. All right, buzzers. We've been using buzzers a lot in this class, but I don't think I've ever introduced the official schematic symbol for a buzzer, so there it is. And by the way, this document that I've listed on here, let me tell you what I want you guys to do. Not right now, but sometime before we meet next, I want you to download this file and I want you to have it printed and by your side next time we meet, because we're going to be talking in more detail about it next time we meet. And I want you to have it printed so that you can take notes on it. But for right now, I'm just going to go over it really briefly. Okay, so let me come back into this again. Let me start this going. Okay, so that was the buzzer we just talked about. Okay. And you already pretty well know how to use buzzers, so there's not much more to say about that. Now, the next one here is a capacitor. This is a big one that we do need to know a little bit about. I'm not going to take any time today to talk about it, but just be aware that if you look at it like this, there's two different forms for capacitors. In one case, the two lines are parallel. In the other case, one of the lines is curved. And so they both mean the same thing. It looks a little bit like a battery. The way you can tell that it's not a battery is with a battery, you have one long line and one short line. If the two lines are equal length, then it's a capacitor. And we'll learn later what a capacitor is. And capacitors come in all sorts of flavors, which we will talk about later. Okay, diodes we have talked about. We've talked about light emitting diodes and we've talked about regular diodes. There are a couple other diodes that are worth mentioning. You see on the light emitting diode, now on this picture, it's hard to tell because it's a low res picture. On the light emitting diode, the arrows are pointing away from the diode, so it shows light going out. On a light activated diode, it works kind of like a photoresistor, is that if light falls on it, then it conducts electricity. If light doesn't fall on it, then it doesn't conduct electricity. So we're not really going to do anything with them. You just need to be aware of them. Now, there is a thing called a Zener diode, which I will talk about later. But the way that you can tell that it's a Zener diode is it has this, here's the regular diode, and then it's got this Z. Actually, it's kind of a backwards Z, isn't it? A Z goes like that. So it's a backwards Z. And so I don't intend to talk today about how a Zener diode is different from a regular diode, but we will at some point here. Okay, so let's go on. Okay, so then there's another kind of diode called a Schottky diode, which we'll talk about later. A fuse is something that I haven't talked about, but it's really easy to understand. I mean, whenever you make an electric circuit, it's always a good idea to put a fuse in there just to protect things so that if you mess up and somewhere you short two wires together that should not be wired together, so you have too much electricity flowing through there, you could damage the device. So if you put a fuse in there, the fuse will blow when you get too much current flowing through it. And fuses are really cheap and easy to replace. So if you blow a fuse, no big deal. If you blow your device that you're making, then that can be a big deal. And fuses come in two different pictures. Sometimes they put a little sinusoidal thing inside, sometimes they don't. Ground is something we've already talked about. It's basically just the zero voltage point. It's the negative side of the battery. And there are two kinds of grounds. There's earth grounds and then there's chassis grounds. On a chassis ground, this would be like if you've got a car, and so you wire one light, one wire goes to your headlight, and the other wire, instead of going all the way back to the battery, you just connect it up to some metal piece on the chassis of the car. And so then the electricity then flows through the metal chassis of the car to get back to the battery. So we're not really going to talk about those, just be aware of them. An inductor is something that we'll talk about later. Light bulbs, we've used light bulbs. Now, normally we've used LEDs. They're more efficient, but you also could hook in a regular old style incandescent light bulb. And be aware that there are 3 different symbols that are commonly used for an incandescent light. So if you see one of these 3 symbols, that's not an LED, that's an old style incandescent light. And then here's an LED again. The logic gates, we've talked about most of them, and hopefully you recognize the shapes. So we've got an AND gate, we've got an OR gate. A NAND gate is an AND gate followed by an inverter. And so if you look right here, you see that circle right there? That circle there means that it's an AND gate followed by an inverter, so followed by a NOT gate. So we call that a NAND gate, which means it's not after the AND. So it's easy to get confused because you see that these circles right here, some people see the circle and they say, oh, so that circle means that that's a NOT. And that's not the way that they do it. And I realize it's kind of confusing. I wish they would do it differently. So when you see the circle here, that just means that that's a place where you connect it to the other circuits. But when you see the circle right here, that's the one that means it's a NOT. Okay, so what you're seeing right here is an AND gate followed by a NOT, which makes it be a NAND. Okay. All right, and then it also works that way with NORs. And here's a NOT. Okay, and this one is an exclusive OR. So an exclusive OR is like an OR gate with just a little bit of difference here. Let me draw the truth table here. Okay, so if this is your input and this is your other input, and then this is your output. Okay, so this is in. So with an OR gate, if A is low but B is high, then the output will be high. If A is high and B is low, the output will be high. If they're both low, the output will be low. Now, with a regular OR gate, if they're both high, then the output will be high. But that's not the way it works with an exclusive OR gate. With an exclusive OR gate, if they're both high, then the output is low. So the output will only be high if one or the other exclusively, separately, is high. If they're both high, the output is going to be low. So just be aware of that. That's called an exclusive OR gate. And it looks like an OR gate, but it's got that extra little, this extra little line right there that you see right there. That's the way that it tells you that it's an exclusive OR gate, not a regular OR gate. Okay. Hang on while I do a little erasing here. Okay. All right. A microphone We're not going to do any more with microphones. Just be aware that's what it looks like. This is what it looks like if you hook up a motor. This is what it looks like. It looks like if you hook up an ohm meter, or if you just take a multimeter and set it to read resistance. This is the way that you would show it. A potentiometer is a variable resistor where it has 3 terminals. And so this little arrow that you see right here, that arrow can slide over here or can slide over here. So it goes back and forth, okay? And so what the current does is the current comes in here and then it goes out that way. So if the arrow is slid over here, then the current doesn't go through very much of the resistor. So the total resistance is going to be low. But if you've slid that arrow over to here, then the current has to go through all of that resistance before it can come out here. So you see how it works. So this extra terminal over here doesn't really serve a purpose, and yet it's there. So later, before the semester is over, I do intend to do some work with potentiometers, just so you can see how they work. They are kind of important and you do need to know them. But for right now, just recognize that it's a variable resistor that has 3 terminals. Now, there is another thing like it, that's this thing right here. A rheostat is a variable resistor, but it only has 2 terminals. They're made a little differently. So a rheostat and a potentiometer are fundamentally the same thing. It's just one has 3 terminals, the other has 2 terminals. A power meter is something we're going to talk more about later. Power is something very important that you need to know about. And I don't want to take time today, but before the semester is over, we will talk about it. Okay, with resistors, the symbol that you're seeing right there, that's the symbol that I normally use. But you should be aware that there is another symbol that's sometimes used. These letters that you see, the IEEE and the IEC, those are different electrical organizations. People who work on electronics, they group themselves together and they have conferences and they go to learn about things. So IEEE is the organization that electrical engineers normally join, whereas IEC is an organization that electricians normally join. When I say electrician, I mean, like, let's suppose you're building a new house and somebody has to come in and wire the house, wire in all the lights and all the, all the plugs and everything. The person who does that would normally be a member of IEC, whereas the person who designs computers would normally be a member of IEEE. So people who do household construction, when they draw resistors, they usually use the little rectangle here rather than the squiggle line. So you need to just be aware that when you take the test, when we come back from the winter break and you take the test, the resistors might be shown as little rectangles or they might be shown as little squiggles. Just recognize it either way. Okay, a speaker is pretty self-evident. I mean, it looks like a speaker. Now, switches are something that we're going to be talking about because it's very important, and I don't want to take the time right now to do it. There are lots of different kinds of switches. The switches that we've been using up until now have been this kind. The ones, those little buttons in Tinkercad that we put into our creations, those were what are called momentary switches that are normally in the off position. And so when you push the button, then as long as you're holding the button down, then electricity can flow through it. But as soon as you take your finger off the button, then it springs back up and electricity stops flowing through. So those switches are called momentary switches that are normally in the off position. But there are lots of different types of switches that you need to know about. I don't want to take the time today to talk about them, but we will talk about them later. Relays are switches where you send in an electrical signal and the electrical signal flips the switch so that you can have something really weak and low power like an Arduino. Okay, so like for instance, let's suppose that over here you've got an Arduino. not an Arduino, an Arduino. Okay. All right, so Arduinos cannot put out very much current, but they can put out enough current that they can activate this electromagnet, and this electromagnet will cause the switch to flip. So what you could do is you could have a wimpy little Arduino over here controlling some really big power supply. You know, maybe you got like 100 volts, or maybe you might even have like 500 volts, some really super massive power supply that's connected up here to some really big motor or something like that. Okay, so this motor requires way more voltage and way more current than the Arduino could possibly supply. But the Arduino can give enough to flip the switch, and so then the battery then runs it. So what we did was we hooked up a transistor. So we used a transistor like this, and transistors work great, but those little transistors, they can only handle maybe 1 amp. If you try to put more than 1 amp through them, they don't work. So this is a mechanical relay. It has a little magnet in it. And so when the Arduino activates the magnet, then you got a mechanical switch that actually flips positions. And then you can have massive amounts of current flowing through the relay there. So relays are good things to know about. We don't really need to say any more about them than we've already said. Okay, so let's see. All right, here's a couple more switches we'll talk about later. A thermistor is basically just a variable resistor where the resistance depends on what the temperature is. Okay, so when the temperature changes, then the value of the resistor changes. So they're useful for applications like if you want to put something in a furnace to make sure the furnace reaches the right temperature, or maybe an oven, you want to make sure the oven reaches the right temperature. They're useful for that. Transformers are used to change one voltage to a different voltage. We'll talk more about those later. Transistors are things that we've talked about. We haven't covered all of the different types of transistors, but we have talked about bipolar junction transistors. So NPN transistors and PNP transistors, we've talked about those. If you take two transistors and you put them together, then you have what's called a Darlington pair. So we've talked about those. There is another type of transistor that's called a metal oxide semiconductor field effect transistor. It's called a MOSFET. And we do need to talk a little bit more about those. Voltmeter is self-evident, okay? And then the last ones here, we have, if you have wires and you want to show that the wires are connected, the normal way to do that is to show a little dot. So if you see a dot, then you know that the wires are electrically connected to each other. If you don't see a dot, then you know that the wires are not electrically connected to each other. But sometimes people do get confused by this. So the better way to show when they're not connected is this little thing here. So you see what we've done is we've got a wire, and then we give it a little hop, and then over here. So that's the way of showing that wire that's passing over the top there is not electrically connected to the wire underneath it. Okay, so that's it. That's the list of things that you need to know. Now, I don't expect that you guys are going to memorize everything that I just said. So we will be using this list as the next couple of weeks go by. So please, like I said, please click on this link here, download the file, print it out, and I want you to have it by your side next time we meet, because I'm going to be giving you little tidbits of information about each one of these things. And I'm going to want you to write down on the sheet what they do. And you will need to memorize them at some point, but not right away. But definitely by the time that the winter break finishes, you will need to have them memorized by then, because that's when you guys will be taking this state mandated test. Okay, so are there any questions about that little checklist there? Not seeing any, not hearing any. Okay. So let's see. Now, did I turn on the recording here? Yeah, I did. Okay, good. Good. Had me worried there. Okay, so let's go back into the modules here and let's talk about the assignment that is due tonight. What we're going to do for the next few minutes is something that we've already talked briefly about, but only briefly. And so today we need to go into it in more detail. And that's this thing about color codes for resistors. Okay, so if you click on that, this is the assignment that's due next time we meet. And let me click on preview so that what you see on the screen looks a little more like what you will see when you go to Canvas. Okay, so we have talked about the fact that there is a color code scheme, but I didn't require you guys to use the color code scheme because on Tinkercad, you don't really need to worry about it. On Tinkercad, you can just click on the resistor and the little box opens up and it tells you what it is. But you need to know the color code because when we take the test next January, I guarantee there will be lots of questions. For some reason, whoever wrote the test, they think it's really important for you guys to know the color code and you have to have it memorized. Okay, so let's talk about how this works, even though we've already talked about it before. It's been a while and I realize you've probably forgotten. So over here is the helpful mnemonic. Okay, you guys know what a mnemonic is? A mnemonic is just a little way to associate the thing that you want to memorize with something that helps you to remember it more easily. Okay, so the mnemonic that I recommend that you guys use is this one. It says, bad boys race our young girls, but Violet generally wins. So imagine a bunch of little kids in tricycles and they're racing each other. And there's this girl named Violet, and she generally always wins, even though all those bad boys, they're convinced that they can beat this girl, right? She's just a girl, right? But it turns out she can whoop them. Okay, so she's the fastest tricycle rider. So imagine that in your mind. So bad boys race our young girls, but Violet generally wins. Okay, so the B for bad corresponds with the color with the B for black. Okay, so black, brown, red, orange, yellow, green, blue, violet, gray, and white. So there are 3 letters in here that are all B's. And so you just got to remember them. You'll just have to do whatever you can to remember them. So one of the mnemonics that used to be commonly used was something about black bears raiding our garbage cans. And so that helped you to remember that the first B you see there is black. And then bears, sometimes they're black, but more often than not, bears are brown. So black comes first and then brown. And then the next B that you see way down here, that's the one that's blue. Okay, so I want you guys to memorize this. And in the quiz that's going to be your homework tonight, it's going to ask you, I'm going to pick a color like I might say red. And I might say, what is the number that corresponds to red? And I want you to be able to answer that question from memory without looking in your notes. So please memorize this. Okay, bad boys race our young girls, but Violet generally wins. I want you guys to memorize that. You do need to know them from memory. Okay, and then the way that you use them is shown over here. So most of the resistors have 4 color bands, but there are some resistors out there that have 5. These are pretty rare nowadays. You don't see very many of the 5 color bands, but you do need to be aware that they do exist. Okay, so the way that it works with color bands is you need to hold the resistor so that this band right here, which is either going to be gold or silver, okay, that needs to be on your right side. So if you're holding the resistor and you don't see the gold or silver one on the right, then flip the resistor over You definitely want to have that gold or silver one on the right. Okay, so the first color band that you see, that's the first digit. So in this case, let's see, where did my glasses go? I can't. Oh, here they are. Okay, so that first one there looks like it's green. You guys agree that's green? Okay, so green corresponds to 5. So that means that the first digit here is a 5. Okay, that second digit right there, that looks kind of blue to me. All right, so I come over here and I see the blue corresponds to 6. Okay, so the first two digits in my resistor there are 5 and 6. Okay, now the next one here you got to be careful with. This next one tells you how many zeros to add. Okay, so in this case, it looks like it's red, or is that orange? No, I guess that's orange. Okay, like it's hard for me to see colors very well. Okay, so that one looks orange to me. So I look over here, so orange is a 3. So that does not mean that the next number is the number 3. That's not what it means. Okay, what it means is that I'm going to add 3 zeros. Okay, so this resistor here corresponds to 56,000 ohms or 56 kilo ohms. Okay, and you can see over here. Okay, all right. And now this last digit, this last color band here, that tells you what is the tolerance. Because if you were to own a factory where you made resistors and you say, well, I'll just make every resistor exactly the same, I got bad news for you. It's not easy to do. You're going to find that there's always going to be a little bit of variation from one resistor to the other. Okay, so the last band, the one that's either gold or silver, that one tells you what is the tolerance. So if it's gold, that means that it's plus or minus 5%. If it's silver, that means it's plus or minus 10%. Okay. Now you'll see here that they do have a thing for plus or minus 1% and plus or minus 2%, but I have never seen resistors that have that. Any resistor that I've ever seen, and I've looked at a lot of them, it's either gold or silver. You never have the other option there. And on the test, I'm quite sure that they will not ask you ones about this. Any ones that they ask you on the test, that last band will either be gold or silver. Okay, so in this case, we can see that it's silver. So that means that it's plus or minus 10%. Okay, so I trust that you guys know how percentages work. So let's say that I want to know what is 10% of 56,000. Well, what I just do is I take 56,000 and I multiply that by 0.1 because 10% that means 10 divided by 100, which is 0.1. Okay, so that means that my plus or minus 10% tolerance here gives me, so if I just kill one of those zeros, so if I multiply it by 0.1, I just move the decimal over one. So that means it's plus or minus 5,600. So what that means then is that if I were to pick up some resistor at random that has this color code on it that you guys see right here, okay, that thing might be as low as 5,600 minus, I'm sorry, 56,000 minus 5,600, which is, let's see what that works out to be. So 56,000 minus 5,600. Okay, so that works out to be 504. Or I'm sorry, 50,400 is what I meant to say. Okay, so this is the lowest that it might be. But it also could be 56,000 plus 10%, which is 5,600. Okay, so in that case, if I add 5,600, I'm going to get, okay. So I get 61,600 ohms. Okay, so what that means is that if I pick up a resistor that has these color bands on it that you see right here, okay, the actual resistance could be anywhere in this range. It could be as low as 5,400, could be as high as 61,600. Okay, it'll be somewhere in between there. Then this number right here, this is what we call the nominal. Okay, the nominal value. Okay, but a real resistor is probably not going to be exactly equal to that nominal value. It'll be close. And this number here tells you how close it'll be. So if that last band is a silver, then it's going to be within 10% of the nominal value. If the last band there is gold, then it's going to be within 5% of that nominal value. And obviously you pay a little extra for the gold resistors than you do for the silver band resistors. Okay. So any questions on that? This is something that we did talk about before, but I didn't put much emphasis on it. But I'm now going to put emphasis on it from today forward. From today on, you must know this color scheme and you must know how to calculate it. I'm not seeing any questions, not hearing any questions, so I'll presume that means you guys are good with it. All right, so if you go to Canvas and you open up this assignment, you'll see that there's a copy of what you see right here. And then there's a bunch of questions. Okay, so it's, what color does violet represent? What color is this? And then here's a resistor that has these color bands. So what is the nominal resistance? What's the lowest it might be? What's the highest it might be? So basically it's just making sure that you guys understand how to do what we're doing here. But I want you to note one thing that's really important here, guys. Right here. Try to when you take the quiz, I want you to do it from memory. Now, obviously, I'm not there to monitor you. So if you were to cheat, I would have no way of knowing that you're cheating. But when you cheat, you only cheat yourself. Because the purpose of this quiz is for you to learn what you need to learn so that when you take the state mandated test in January, you'll get a better score on that state mandated test. So when you take the state mandated test, you will have to do it from memory. So start now. When you do the quiz, do it from memory, okay? Now, I am going to give you 2 attempts on this quiz here. So if you don't get a perfect score the first time around, you can go back and I will give you a second chance on this quiz. Okay, so are there any questions on how to calculate the resistor values? Not seeing any, not hearing any. Okay. All right. So we have 35 minutes left before the class period ends. I'm not going to require you to stay on Zoom. If you want to type bye into the chat box and head out and then just do this quiz on your own, I'm okay with that. But you do have to do the quiz before we meet next time. Now, if you have any questions, I will stick around here on Zoom to answer any questions you have. But otherwise, goodbye and see you later. I'll go ahead and turn off the recording here so that if you wanted to ask questions without them being recorded, you can do that.